let's move to the next topic, which is GARCH model. Indeed, more popular one. Okay, more general one. So GARCH is Arch is rarely used. GARCH is actually more GARCH is used. Okay, so again, shock at is sigma t epsilon t. Epsilon t is mean zero, variance one, and then square. Again, we model the square term sigma t square, which alpha zero plus some. This is arch part. We the stack the shock, square of the shocks, and then we have now kind of uh, arch part. Okay, so it is also dependent past sigma square, right? So we have some analogy with ARMA model. So in some sense, this part, first part is similar to MA model, and second part is similar to AR model, right? So epsilon epsilon t is defined as before, where alpha 0 graded 1, alpha I 0, beta j graded 1, and then alpha plus beta should be less than 1 to make it stable. Again, this condition is analogous to those of ARMA model. Reparameterization. Eta t is at square sigma t. Eta t is uncorrelated series. Then if we use this one, the GARCH model becomes at square alpha 0 is something like this one. Eta t minus j. Okay, uncorrelated series. This is basically ARMA form for square the series at square, right? So because eta is shock, okay, shock of this square term. That means the shock of the square. So we can see it, the analogy more clearly. Now use it to understand the property of GARCH model, i.e. moment equation and forecasting, etc. Now we focus on RC11 model. The GARCH11 model, the simplest one, then sigma t square is alpha 0 plus alpha 1 a t minus 1 square, and then sigma t minus square. Weak stationarity, so uh, both alpha beta t less than 1, then sum should be less than 1. Okay, then we have stationarity. And then volatility cluster. Sometimes volatility in some period volatility is very high. Market is very volatile. Other period market is stable. Now we have heavy tail. If this condition holds, then fourth moment looks like this one. Third moment looks like this one. Yeah, greater than 3. For one step ahead forecast, of course, then sigma h square is alpha 0, and then, alpha h square and sigma h square. For multi-step wide forecast, use h square and t square and square and rewrite the model as sigma t plus square is alpha 0, alpha 1, beta 1, sigma t square, and alpha 1, sigma t epsilon t square minus 1. Okay, so we can write this way. Two-step ahead volatility is now we can use the recursive relation. Okay, h square is then only depend on this one. Two-step ahead. Two-step ahead. In this equation, okay, this is more convenient. This term becomes 0, right? In general, we have alpha h L step ahead model is alpha 0, alpha 1 plus beta 1, alpha h square, L minus 1, when L is greater than 1. The result is exactly the same as the ARMA 1 model with AR polynomial 1, alpha 0, beta 1, B. Okay, so we have example. Monthly excess return of SMP5, and this started from this one. The fifth Gaussian AR3 model. AR3 model looks like this one. Okay, with sigma SQ this one. If we use GARCH effect, we take it to GARCH effect, and GARCH 1 model, we have this estimation. And unconditional one is 00352. So this is quite close to this one. Close expected value. Okay, so all AR coefficients are statistically insignificant here. Okay, insignificant. A simplified model is RT is this one. So indeed, and then 80 square is looks like this, and the GARCH 11 model. Okay, here. So this is SMP 500 model. On further exercise, you can use Korean data or Chinese data to estimate this GARCH 11 price together with mean. Okay, we can do the model checking and then forecast. One step away, the forecast is this one, and horizon, over the horizon we can do volatility estimate. Okay, now our demonstration looks like this actually. So well, you can try this R. Okay, so we can instead use Python. Okay, so you can use previous example. Okay, so next next I want to do the same thing with now GARCH, let's say 2-1 model. Okay, GARCH 2-1, GARCH 2-1. Okay, generate the process, and then regard, and then estimate the process. Okay. Show the estimation results, and then original data, original volatilities, and estimated volatilities. Okay, sure, let's go through the step GARCH 2-1 process. Same seed, very good. Okay, explanation. Okay, so let's copy the code now. Copy the code, and then here add the code, and then I hope it works. Okay, it seems working, no error. So okay, let's take a look at the line by line. Okay, check the, okay, this is original data, this is the simulated data, and the red one is the original simulated volatility, true volatility, and this is the estimated volatility. They are, red one is the true one, blue and green one is estimated one. They are not exactly same, but almost identical. So estimate is correct, and then okay, this is the estimation result. So let's see. Okay, so import numpy as np, import matplotlib, pipeline as plt, and from arch model we set the seed for reproducibility, and we define the parameters for GARCH 2-1 model. Okay, so GARCH 2-1, so alpha 1, so alpha constant term is 0.1, first alpha 3, alpha 1 is 0.3, alpha 2 is 0.2, and beta 1, okay, this is 0.4. Again, we generate 1000 simulation. Okay, we fill first epsilon 0, and then sigma 0, and now we generate epsilon. Epsilon alpha is, first we have AR part. Okay, this is AR part, alpha is AR part, so it is the, actually it's arch part, so we give two orders. Okay, so alpha 1, and then t minus 1, and then t minus 2. So it should start at 2, right? Because we have t minus 2. And then beta, this is a GARCH part. Okay, we added it first. And epsilon t is, of course, we put 0 in mean, and then the root of sigma t squared, sigma tt generated one. And now you can do the plot. Plot the simulated GARCH 2-1 process with original volatility. Plot figure size. Figure size is this squashed one, and then we plot estimated sigma 2. Okay, and then okay, here, okay, So first, and then we simulate the GARCH1 process. Okay, this is blue, and then we plot original series, original volatile sigma 2, which is red. Now we estimate the model, estimate arch model epsilon. Epsilon is the data. Okay, and then use GARCH P2Q1 and do this one. Okay, and then we do this one. Okay, actually we can make it more fun. Okay, so okay, by the way, let's check the answer. So original one is what? It is a 1324, and then estimated is the, well, 1315. So it's different, well, but it is kind of different. But anyway, the estimated processor virtually basically is very similar, so we are fine. We are fine with that. Okay, actually we can change it. So in fact, simulated store the simulated epsilon as a CSV file. Next, upload the CSV file and then estimate it. Okay, in practice you have some raw data, right? So this is more realistic. Hmm. Next, nice, but I need a Python code that save the output as a CSV file, and then the Python code to upload the CSV file and then estimation the process. Okay, it's doing well. So okay, now say so we have a two part. The code is made two parts. So first part, let's copy the code and then we run the code. Okay, first now we generate GARCH2 process and create the data frame, store the simulated data. Okay, so data frame we save epsilon as this one, and then we epsilon df to CSV file, simulated epsilon CSV. Okay, so if we check the folder, yes, we have a simulated epsilon dot CSV file. Now next we have to upload this file, and then do the estimation. Okay, so close, and then second part of the ChatGPT part 2 is this one, upload the CSV file. Okay, copy code and then upload. Okay, do it, and then yeah, this part epsilon df pd read CSV file, so we will read this file. Okay, here we read this file, and then we extract only values, and other part is exactly the same. So again, we have a nice estimation, nice GARCH estimation here. Okay, now turn to student T innovation. Until now we use normal distribution, but we can also use student T innovation, something like this. Okay, for now, until now we learn the GARCH model. Now, well, next we get more variation of GARCH model. So iGARCH is also popular model. iGARCH 1.1 model is this one. iGARCH 1 model is now beta 1. So beta 1 and then 1 minus beta 1. So we can reduce number of parameters to estimate. right? For the monthly accessory S&P 500, we have this one. And iGarch model is actually iGarch model is very convenient, convenient because there's a very convenient recursive relationship such that else future variance is simply this one. Okay, first one and the L minus 1 multiplication of constant sum. So very convenient. H is a forecasting already. Effect of sigma squared H1 on future volatility is persistent, and the volatility forecast form a single line with slope alpha 0, right? So profit as L is increased for the future is increased with L, and the slope is alpha 0. Okay, and special case when alpha is 0, volatility forecast becomes a constant. This property used in risk metrics to bar calculation. Again, risk metrics is a very popular component. On iGarch 11 model for the monthly excess return of S&P index from this period is looks like this one. And we have R demonstration for iGarch R. Okay. Another alpha Lugach can be used to fit the volatility model. Okay. In Python, we can do that too. Okay. Next, do the same for iGarch. Now 1 2. Okay, iGarch 1 2 model. So if we step to simulate, first we simulate. Now we have 1 alpha and 2 beta. Again, simulate iGarch. This is strange. Let's say something wrong. Okay, something wrong. Okay. Actually, okay. iGarch 1 1. Okay, iGarch 1 1 model. And then maybe we have to explain what is iGarch in Python. Python doesn't know iGarch model much. An iGarch model looks like this one. So we have to teach Python what is iGarch model. For your information, check the explanation for iGarch 1 1 in the attached image. Okay, and then you can attach the image. Do it again. Why it doesn't work? Okay. Okay, let's do it again. I can simply change it slightly. Oh yeah, it is mine. Right. 4 and 06. Okay, it should be 1 in iGarch model. Okay. Okay, nice. Yeah, it's already imposed and upload model. And then we have GARCH P1 Q1. It does not specifically have iGarch package. It does not use specific iGarch package. It is basically same as before. iGarch. Okay. Is there any special package for iGarch? Maybe not. In Python, Arch package in Python. Okay. Yeah, this is basically repetition of the previous. So iGarch model. So we have to define custom iGarch model. Okay, let's do it. So again we code, okay, and then run. Simulate epsilon I GARCH. Okay, so let's check it. Okay, simulate epsilon I GARCH. Okay, we have the data now. Okay, now it is a bit advanced Python coding. Okay, now we write our own class. Yeah, there's error. Oh, we can copy this one to the ChatGPT. That you are wrong. Here's the revised one. But there's no mistake in part one. I ChatGPT generate from the part one again. Okay. Yes, it is basically doing the same thing. Basically using GARCH one model. Or just a parameter to enforce I got you constraint. Well, this is wrong. Clearly wrong. Well, this is wrong. I don't like it much. I don't like it much. Okay. Okay. I don't like it. It's not so well I cannot ChatGPT doesn't know the doesn't know the library for iGarch. I have to do search, but anyway, we can let's run it. It is not entirely I'm satisfied with this one, but yeah, the sum is very close to one though. Okay, robust. Okay.